Okay. Hi, everybody. Welcome to Analytics in a Day. We're really excited to show how analytics can transform your business, and more importantly, what concepts you need to understand to be able to do more with data at your company. So to kick off, I want to go ahead and introduce the team that's going to be supporting this workshop today. So we've got Aaron Woodward, who's going to be leading the labs later on and also contributing on the slide deck. And then Lindsay Rain is going to be our moderator. If you need to ask a question and you can't get my attention, just give Lindsay an @ mention in chat and she'll be sure and call it out. We've got a small enough group today that we can also probably just unmute and, or raise your hand, that kind of thing. And then finally, I'm Spencer Cook. I'm a senior data scientist at Valorum Reply. I focus on all things big data, data science, IoT, all that kind of fun stuff. So with that, let's go ahead and get started. So I'd like to start by going around the room real quick and just having everybody introduce themselves, their company, and maybe how much exposure they've had to advanced analytics so far. So unless we have any volunteers, I'll just go down my list. So Brandon.
Hi, I'm a technical analyst at Valorum Reply, and I have had almost no dealings with data analytics.
Cool.
So I'm excited for this little introduction.
Yeah, this will be a great intro. Okay, Christian. How about Duncan?
Hi, I'm Duncan, data analyst, and never really gotten into the analytics too much, so looking forward to doing that, kind of seeing how it works.
Awesome. Aaron, I know why you're here, and apologize if I pronounce this wrong. J.R. Alman?
Yeah, this is me. Yeah, I am Mani. I'm from Cluster Reply, Germany. And you can see my colleague there, Naki. So we are also the data analytics team in Cluster Reply, specializing with Microsoft. So we wanted to have a glimpse of your workshop so that we can also learn from you, and also maybe ask some good questions where we can also learn together in this horizon. Yeah, thanks for the opportunity.
Glad to have some fellow repliers on. Definitely don't hesitate to reach out to me after if you have any more questions, Mani.
Yeah, sure.
Hey, Megan.
Good morning, everyone, or good day, depending on where you're at. Account Executive Valorum. I have to talk about this, so I'm here to dig deep and learn exactly how great this is for a business. So I'm looking forward to this. I'm a beginner, haven't come across it a lot before.
Awesome. Yeah, feel free to reach out to me as well. Naki?
Yeah, hi. Just the same like Mani. So also just so I'm more a data analyst, so working a lot with Power BI for Cluster Reply, and I would like to see how I can, let's say, improve my knowledge also in case of data engineering and all those things in the cloud. So very excited to see use Spencer, what we can do with all the things, and yeah, let's see. Thank you very much.
Yeah, thank you. Praveen? I see Praveen went offline, it looks like. Stephen?
Yeah, I'm with Valorum as well, kind of like Megan, new and looking to learn and keep building the knowledge base.
Perfect. And then Zayad?
Yeah, hello. Can you hear me?
Yes.
Yeah, great. Because I usually got just a problem with the mic with the team. So I'm also from Cluster Reply Germany in the data analytics team with Naki, Mani, and Christian. We are all here together just to attend this interesting workshop.
Sweet. Okay. Cool. Sounds like we've got some new people, some people who are interested in analytics. So this is a great chance to get exposed. So let's go ahead and hop in. So this is going to be our agenda for the day. We might try and get started with the labs a little bit early just because sometimes they take longer to provision, depends on what kind of mood Azure is in that day. But we're going to be looking at how to harness the power of analytics, experience a new class of analytics with Azure Synapse, getting started with your first analytics project, and then we'll have our hands-on labs. So really it covers the breadth of cloud analytics capabilities. You learn how to do an analytics pipeline that goes from data ingestion all the way up through business intelligence, learn about self-service features, and ultimately learn how to enable a more data-driven culture in your business or for your clients. And then later, like I said, we'll get into sort of the hands-on. So let's look at how to harness the power of analytics. You know, that's broadly why I think a lot of us are here today. So let's talk about the state of analytics today to start off. So at Valorum, and Microsoft is behind this all the way. We believe that all businesses are data businesses. So that means that vastly different things for different organizations though. So let's take a minute and level set on what analytics can do for a business, how the cloud can enable better insights, and then the inherent tension in our traditional analytics approach. And then finally, what our ideal end state for analytics looks like. And then we'll take those ideas and build on them throughout the rest of this presentation. So today, analytics is at the heart of every modern business. Over the years, we've seen front row that digital transformation is occurring across all industries and regions around the world. In 2020, we've seen that digitally transformed organizations have successfully adapted to sudden disruptions. The same element that lies at the heart of digital transformation is also underpinning of organizations that have proven most resilient during turbulent times, and that's data. Data is what enables both analytical power, analyzing the past and gaining new insights, and predictive power, and also predicting the future and planning ahead. From the corner store that just has online accounting and stock keeping, all the way up to the largest online retailers, every organization fundamentally runs on data. Those that manage, govern, and secure data effectively will thrive in this new data-driven economy. Of course, it's one thing to gather and manage data, but it's another thing entirely to be able to make decisions based on it. And this is where analytics comes in. Dashboards and reports support awareness of the current state of the business. BI and visualization strengthen the role of knowledge workers with informed insight, and augmented intelligence can discover information and patterns that even experts may overlook. And while analytics is important, it's increasingly evident that not all analytics are created equal. Data science takes analytics to the next level. It enables automated insight with a depth and scale beyond the abilities of human analysts, allowing businesses to understand their data better and faster than ever before. Using machine learning and artificial intelligence to drive autonomous processes and decisions, organizations can respond intelligently. In order to fully achieve automation and depth possible from analytics, businesses need scalable solutions that won't get stuck in the data center. And that's where the cloud comes in. The cloud enables companies to start and scale projects easier and faster than they could on premises, making it the default environment for new technology initiatives. The ongoing shift to cloud native applications, including collaboration and file sharing platforms, puts even more data within reach for analytics. The benefits offered by cloud, as well as its proven security and reliability, has led to a mass migration. Even organizations bound by governance to maintain on-premises data management tend to take a hybrid approach, and they use some cloud services in order to take advantage of the cloud as much as they can. Cloud-based analytics platforms eliminate the need for large CapEx investments. Deploying in the cloud is faster, easier, and more flexible than a traditional data solution without the need for high hardware and infrastructure costs. Iterating designs and handling diverse data is far more efficient for an on-premise solution. And the cloud makes world-class performance and elastic scaling available to all users. As the volume and variety of data continually expands, modern cloud-based data services serve as the home for all data. Workloads of all types, from enterprise models and BI sandboxes to predictions, can be stored, managed, and provisioned together. The cloud can effectively handle different processing schedules, for instance, enterprise ETL runs or self-service explorations, without needing someone to manually juggle them. And it both delivers enterprise-wide reports and enables ad hoc data discovery through a variety of visualization or data science tools. If you're hearing that there are lots of choices and endless capabilities for analytics in the cloud, you're right. If you're wondering if all those choices and capabilities make it hard to know everything you need to know to do everything you want to do, you're not wrong. Today, the industry has evolved analytics to the point of near paradox, or so it would seem. Industry analysts expect it will quadruple in the next 5 years. However, if we continue at today's rate, only 27% of that data will end up being analyzed. The problem is that much of this data is not understood, so it's shunted off or simply ignored. When we talk to Fortune 1000 leaders, they tell us that although analytics and AI are their top investment, data initiatives in these areas can be prohibitively challenging. As you can see from the numbers, 80% struggle to advance their data insights. 55% blame data silos and management issues as roadblocks. And further, 50% admit that they don't treat data as a business asset. And it's not because they don't think that it matters. They just don't have the processing capability to achieve their goals. Part of the underlying problem has to do with how the industry has approached analytics up to now. For decades, specialized technologies like data warehouses and data lakes that handle specific types of data have helped us collect and analyze data of all sizes and formats. This created niches of data, technology, and expertise, which we talked about today as silos. And this has led to the ultimate paradox of analytics. The more that we apply technology to integrate and analyze data, the more silos that we create. To harness the power of data, we need to break down silos without creating new ones and approach analytics holistically. On top of the data warehouse and the data lake, organizations still need more technologies for visualization, reporting, data science, governance, etc. Each new technology that you adopt creates another siloed operation. The task of connecting all these systems required specialized skills, building out protocols, and duplicating data, which essentially just creates another walled-off data set. But when you take a step back and consider the traditional approach to analytics, that is, building a new system for each activity, that made sense at the time. However, as the volume and complexity of the systems continues to increase, adding more and more technologies only compounds the problem. There comes a point in which the complexity of adding another analytics technology outweighs the benefits of the technology itself. A holistic approach is then key to unlocking the paradox, because the goal for modern organizations is simplicity and accessibility across data's growing complexities. Today, it's common for decision makers to increasingly reach beyond traditional reports and dashboards to engage with new sources and tools, big data, machine learning, even AI. However, the more advanced the technology, the more siloed the data and the skill sets. The harder it can be to understand what the direct implications might be on the larger picture. That's why we took a new approach to analytics in Azure to enable a more holistic experience of business insights. Microsoft has re-architected their operational and analytics data sources to take full advantage of a new cloud-native infrastructure. This fundamental shift, while maintaining consistent tools and languages, is what enables long-held silos to be eliminated across skills, technology, and data. So decision makers from across the organization are then better able to access and understand what insights they need. At the core of this is Azure Synapse Analytics, a limitless analytics service that brings together data integration, enterprise data warehousing, and big data analytics into a single service offering unmatched time to insights. With Azure Synapse, organizations can run the full gamut of analytics projects and put data to work much more quickly, productively, and securely, generating insights from all data sources. And importantly, Azure Synapse combines capabilities spanning the needs of data engineering, machine learning, BI, all without creating silos in processes and tools. Customers such as Walgreens, Minerta, P&G have achieved tremendous success with Azure Synapse. And now we move to the globally general availability. So before it was just in private preview. Now it's generally available on your Azure sub. And so every customer can get access. So up until this point, we've talked about the value of analytics, the role of the cloud in modern analytics, the paradox many of us face today in our environments where we try and do analytics, and the ideal end state that enables a fluid continuum of analytics for every user, in which we introduced Azure Synapse Analytics. Now we're going to double click into Azure Synapse to describe a little bit about how it works and give you some tips on how you can use it to optimize your analytics. So Azure Synapse provides a unified experience that brings together data ingestion, big data analytics, and data warehousing, all at a cloud scale. Instead of stitching together a multitude of services together or creating a siloed point solution for just one of these three areas, Azure Synapse unifies your data tasks, and your data teams with a limitless analytics service that does it all. It simplifies the monotonous but necessary data chores that every team must do, such as securing pipelines, assigning permissions to users for each service, building firewalls, so on and so forth. With Azure Synapse, all you do is secure your Synapse Studio, and Microsoft Azure teams take care of the rest. Simplified analytics is what you have been asking for, and simplified analytics is what Azure Synapse delivers. Creating an analytics service that unifies these divided worlds and redefines what capabilities an analytics service must provide is the result of a multi-year project. We set out to re-architect and create the next wave of query processing for modern workloads. As modern workloads require both SQL and Apache Spark, Microsoft saw that customers would need a cloud-native analytics service engine that converged big data and data warehousing so that they could use limitless scale on unstructured, semi-structured, and structured data. The result is a new cloud-native distributed SQL engine that powers Azure Synapse. With deep integration of Spark and SQL engines, Azure Synapse is enabling a new level of collaboration among data professionals that previously was not possible. Given Synapse, it's nice to have a choice about how you allocate and consume resources as well. Today, Azure Synapse offers both serverless and dedicated resource models, giving you more flexibility and better budget control. If you need predictable performance and cost, you can create a dedicated SQL pool to reserve processing power for data stored in your SQL tables. If you need to accommodate unplanned or bursty workloads, you can use the always available serverless SQL endpoint. So I want to dig into the different attributes of Azure Synapse next and talk about how these holistically come together to help you optimize your analytics. I think first we should stop and see if there are any questions in the room. So at this point, if anyone has a question, you can just unmute and ask. Okay, sounds like we're good. Let's start by talking about security. So in the quest to break down silos and empower all users with access to a continuum of analytics, the question of governance and security comes to the top. Azure Synapse Analytics changes the role your IT team plays by providing well-managed tools and services that support effective best practices among business users. One of the ways we do that is by building data protection into the fabric of the service. With Synapse, you get a comprehensive approach to security, from access and authentication to proactive threat protection and compliance. And since it's all built on Azure, that means you get the latest updates and features as they roll out. Microsoft provides you with managed virtual networks that connect your data pools seamlessly and keep you compliant. This way, your team doesn't have to do the specialized work of setting up and maintaining the network. They've also made it possible for you to easily apply your data governance policies too, through native integration with Azure Purview. Azure Purview automatically discovers and classifies data assets based off what you set up and provides end-to-end data lineage. For example, here's a case in which the delivery payment service Grab used Azure Synapse to help ensure it was meeting local data security and sovereignty requirements of the 8 countries in which its customers live. Integrating data might be the biggest problem when it comes to modern analytics. If data is in different silos, how do you connect them? Well, Azure Maps employs a hybrid approach to data integration. Puts everything that you need at your fingertips to bring together different data sources. So whether you prefer to do the coding yourself or use the low no-code interface, then you can create schedules or automate event-based triggers that keep your data current. The low no-code has a familiar Excel-like feel. From here, you can operationalize your data into pipelines that let you transform and visualize your data however you prefer. So if you're familiar with, the Power Query or transformation interface in Power BI, then it's going to be very familiar to you there as well. And I think even data flows in the Power BI service has that. So like they said, it's very easy to, not even going to try that word this early again. Anyway, you can make it so that your ETL pipelines are in a low code or no code interface rather than being stuck in Spark notebooks. With all of these different sources coming together, you might think latency creeps a little bit, but that's not the case for Azure Synapse. Hybrid data integration happens fast here, as in real-time analytics. There's a whole section about real-time operational analytics coming up later, but for now, I want to emphasize that the data integration is what makes this possible without latencies. So if you, by the way, come in at under 90 seconds, then you're already at the 99th percentile for data ingestion. So Synapse makes that possible. We're going to look at the data warehousing functionality in Azure Synapse Analytics that supports your SQL workloads next. It used to be the case that a data warehouse was an enterprise level decision, and it took months or maybe years to get it set up and running just right. And the payback period was months, years, even decades. And that's not the case today. Built on the fully managed elastic platform of Azure, Azure Synapse provides a totally accessible, ready-to-use solution for any size or level of business. It gives you all the features you need in a single tier and provides elastic compute capabilities that can be optimized for different classes of workloads, which goes a long way to helping control your costs. Speaking of control, Azure Synapse Studio provides a unified workspace for your data prep, data management, data warehousing, big data, and AI tasks. The highly visual, code-free interface works for everyone. Here, data engineers can manage data pipelines, database administrators can automate query optimization, and data scientists can build proofs of concept in minutes. Synapse Studio is the web-native interface that ties everything together in one location so that you can do every task you need to build a complete solution. So anyone can use it. It's easy to manage, but does it deliver the level of performance that your business requires? The short answer is definitely. As you can see from the slide here, Azure tops other cloud providers in both analytics field tests from GigaOM, which is derived from the TPC-H and the TPC-DS benchmarks. And the GigaOM field test also revealed that Azure Synapse outperforms Amazon Redshift in 86% of all of the Test H benchmark queries. Azure Synapse Analytics also consistently demonstrated better price performance compared with Redshift and costs up to 46% less when measured against Azure Synapse Analytics clusters running Test DS benchmark queries. You can see all that in the graph. And in fact, the engine running Azure Synapse Analytics is the only platform that completed the TPC-H benchmark at 1 petabyte scale. And this demonstrates the massive concurrency. And this is coming from the Polaris engine, they call it. Additionally, Azure Synapse Analytics makes it easy to both scale in and scale out your workloads for a better management experience. You can use a scale-in approach that allows for predictable cost and simple ways to allocate resources. And you can scale out by increasing the compute power of clusters, as well as using multiple clusters with auto-scale features. This is still currently in private preview. So this is a great example of a bank that wanted a secure integrated data platform it could use to decouple customers from data providers. ABN AMRO migrated 2 outdated Teradata systems to Azure Synapse, where it could easily and quickly develop new value-added services for customers while saving 70% of its previous costs. Pretty great. Speaking of enabling awesome scenarios, next, we're going to talk about how Azure Synapse makes it possible to perform real-time operational analytics for faster decision-making and improved response time. So if you're like other organizations we work with, a significant amount of the data that you produce and need insights from today resides in your operational databases. Historically, it's been nearly impossible to integrate operational data with analytics systems, requiring complex ETL pipelines to perform the two. We set out to remove this barrier and enable a low-cost, cloud-native HTTP implementation with what's called Azure Synapse Link. Synapse Link finally breaks down the barrier that has long existed between the operational and analytical systems. Synapse Link links your operational databases to Synapse Analytics in Azure, which provides you the ability to get immediate insights on your business. In fact, as soon as a transaction is recorded in your operational store, the transaction will be available in a columnar format for analytics in mere seconds. And the best part is, all it takes is a click of the button and Microsoft handles the work for you. There's no need to manage complex ETL pipelines, no need to worry about keeping multiple data copies in sync, etc. Instead of understanding what happened yesterday, last week, even last month, Synapse Link enables you to understand what's happening right now in your business. And in these uncertain times, making decisions based off of now is a very critical business plan for the ability to react to sudden changes. Microsoft introduced Synapse Link in Cosmos DB, and they're getting to the point where the capability is available for other operational stores like Azure SQL Database, Azure Database for Postgres, SQL, MySQL, and MariaDB. Azure Synapse Link is currently enabled for Cosmos DB, like I said, so don't necessarily try and go look at it for SQL databases yet, but it's coming. How does all this work? So you press a button in your favorite Azure database service and a direct link is established with Azure Synapse Analytics. The operational data is then automatically and continuously made available to Azure Synapse in an optimized columnar structure similar to a covering index. No complex ETL pipelines or additional database compute resources are required, resulting in no performance impact on the database itself. Azure Synapse also stores streaming data ingest from IoT devices without aggregation. That's up to 720 gigabytes per hour of raw data coming in that you can use to immediately create rich insights with your business data, which previously would have been isolated in a data lake and data warehouse respectively. And now you can manage all of it using the T-SQL language in Azure Synapse Analytics. So check out this snow production company, Techno Alpine, that used Azure Synapse Analytics to help ski resorts ensure that they were providing just the right amount of snow for their customers. To do this, Techno Alpine needed real-time access to tons of data to make smart predictions with which their current infrastructure could not support. So the Azure Cloud was able to step in and help process that large amount of data. Techno Alpine needed real-time access to their data, but they also needed machine learning capabilities to apply to that data. It's sort of the trifecta of the Azure Synapse value proposition. Now your data engineers and data scientists can collaborate seamlessly using code-free and code-first experiences to train ML models in Synapse, all powered by Azure Machine Learning. Notebooks offer a collaborative code authoring experience for complex predictive models. Whether you use our pre-built models or build your own, automating machine learning takes minutes on Azure Synapse versus days or months, so you can iterate rapidly for greater insights. I'd like to spend a minute talking about the Notebook IDE, which offers code authoring capabilities in Azure Synapse. This is what enables a code-first approach to model development that lets you take your favorite language, PySpark, Scala, or C#, at the same time that your co-contributor uses their favorite language. It also offers an automatic code completion feature called IntelliSense that makes your short work of redundant, predictable coding. You probably use this in Visual Studio Code. I believe even SQL Management Studio and Data Studio have it at this point. So pretty good stuff. Notebooks aren't the only place where you're offered a choice in how you build your models either. Synapse supports industry standards for data types and languages as shown on the slide here. So whether you're landing Parquet data in a data lake using something like Databricks, whether you have ORC records, you might be landing, raw JSON from App Insights. You're able to ingest those and work with them natively. You can also work with standard model storage formats. And furthermore, the engine allows for automatic ML data exploration to help you get the best predictive model possible. You can access all the capabilities through Synapse Studio, and you don't even have to write a lot of new code to do it. Think about that for a moment. With Synapse Studio, you don't even need formal training in data science to use machine learning, at least, these features. I think it still helps a little bit to understand what some of your, error curves and stuff like that are outputting, but you can get pretty far with just this. It also supports code-free ML scoring to help you build the best model possible. This makes it so that nearly anyone in your org can create and access intelligent predictions, all on top of Synapse Analytics. Amerisource version chose Azure Synapse Analytics specifically to democratize analytics for everyone. The company sources and distributes around 20% of the pharmaceuticals in the US, so they needed a centralized platform where business users could run their own analytics without needing data engineers at every step. Azure Synapse Analytics provides a self-service platform that the company uses to predict better business outcomes. And of course, all of these analytical insights mean nothing unless you can understand them. So earlier, we talked about the continuum of analytics in terms of technical capabilities. However, you can also think about analytics along a spectrum of time. Are you answering questions about what happened and why? Can you predict what will happen and how you can bring it about? Think about where your organization is on this curve. As we look at the increase in value on the X and Y axis, we see that value and difficulty have a direct relationship. BI is the beginning of how you can work towards maximizing the value of your data. And then as you incorporate more data faster and bring BI and analytics closer together, you can create insights that allow you to anticipate and react to events. Azure Synapse automatically takes the next natural step in your analytics journey by natively integrating with machine learning as well as Power BI. We've already touched on the integration with Azure Machine Learning, so let's dive into the integration of Power BI and Azure Synapse. But I want to pause again real quick. Does anyone have questions so far about the content on Azure ML or the native integrations there?
Yeah, actually I do.
Yeah.
I have a question for the Synapse link, to be honest. While it sounds good to have the transactional data there, how is it actually working underneath? Do you know? Is it copying the data in a mini bulk, or is it really querying the system? I'm asking due to the data load then.
Yeah. So essentially, you're just using Polybase. And so let me go back to the Synapse link slide, and I can explain that in a little bit more detail. I can even find it. But yeah, you're just essentially using Polybase, and it's sitting on your operational store. And so the Synapse link is just essentially creating an index on top of that, so that the data as it's needed is able to be pulled through and loaded into Azure Synapse.
But
and
the actual
say again?
But the actual load is on the transactional system then.
Yeah, exactly.
Okay.
Yeah, and there's plenty of documentation around it. You know, the one-click solution is always a good start, right? But you're going to want to understand the impact it has. So keep in mind, when we're talking about Cosmos DB specifically, it's pretty easy to reason about the semantics for how it would bring over different rows into your analytical store, because it's perfectly tuned for that kind of operation, right? Being more of a key value pair type database.
Yeah.
I think when it comes to SQL, like Azure SQL, that's when they're going to need to rely on technologies like Polybase, and it's going to be important to have the indexing correct. But for Cosmos, at least, it's pretty easy to just bring over different transactions and apply them against your analytical store. Does that make sense?
Okay, thank you.
Yeah, thank you. So let's hop back over to... Sorry, any other questions before I move on? Okay. So you can use Power BI directly through Synapse Studio. New Power BI Performance Accelerator for Azure Synapse automates the creation and optimization of materialized views, resulting in lightning-fast query performance. This simplifies and heightens collaboration with your data analysts and database administrators, as they can now use the same analytics service for querying data and building and viewing dashboards. Power BI and Azure Synapse unlock big data in a way that would otherwise be impossible. As previously mentioned, it is not uncommon for companies today to have petabytes of data across the organization. Analyzing and extracting insights from such massive amounts of data used to take hours, if not days. Not so with Power BI and Azure Synapse Analytics. Using Direct Query, you can take advantage of Azure Synapse industry-leading performance right from Power BI, without any limits on concurrency. The new aggregations feature in Power BI boosts performance even further by caching data at the aggregated level, enabling instant response times on petabyte scale data sets with trillions of rows. If the user happens to drill down to the detailed level, Power BI will submit a direct query as usual, invoking Azure Synapse lightning fast query performance. How fast? Up to 14 times faster than other cloud providers. And it's up to 94% cheaper too. If you look back at that study by GigaOM, you can see some of those details. Together, Power BI and Azure Synapse gives users the performance they need to do modern analytics. Did we have a question?
Yes, we have a question from Naki.
Okay, hey Naki.
Yes, hi. Just from my side. Just asking. So when I have my Power BI report and I have a direct query storage mode for my data model in Power BI, I'm not sure, but do you pay then, for example, for all the transactions which will happen then with Synapse for all the subqueries, etc. But or is it just, I don't know? It's
So
only just yeah.
It depends on whether you have the server-based or serverless model, right?
Okay.
And that's what they mean by predictive costs. So this is a really good example. So if you're choosing a more traditional pre-allocated storage type, then you're basically paying for a Synapse cluster to be on at all times, right? And however many DPUs you have allocated, you can use some of those or all of them, and you're going to pay a fixed cost every month, right? Even when you're not using it. If you use a serverless model, that's what they kind of mean by workloads that can have big peaks. So let's say that this Power BI that has a direct query is only getting refreshed once a week, right? Then you're not paying for the server when the query isn't running. And then once a week, the server will ramp up, allocate the resources that you need. You pay for those peaks, and then you don't pay for anything else, right?
Okay.
Now, the difference is if the server is already running and it's already allocated to you, you're going to get better performance guarantees, right? Like you don't have to wait for a cluster to spin up. You don't necessarily have to wait in a queue that you're sharing resources on for like a serverless pool, right? But it might cost more. On the other one, it's going to be cheaper, but maybe the query takes longer to load, right?
Yeah. Okay.
So does that sort of make sense?
Yeah. Okay.
Yep. So it's very similar to like a Databricks cluster pool in that way. And there's a new feature coming out. The name just escaped me, but essentially it's another option for cost savings on Spark cluster management, where you're basically using leftover compute. So basically, it's like the lowest priority, whatever compute happens to be left over on certain blades that can't be grouped together into other, paid clusters. You can use those leftover resources at a much more discounted rate. So for instance, if you have an ETL job that only ever needs to run at 4 in the morning and you don't necessarily care that much about speed, then you can run on that type of compute and keep your costs even lower than in this serverless option. So there's lots of different moving parts and dynamics in terms of understanding what the right server configuration would be for any individual client. So I think it's just important to understand what semantics are there and what's available, and then help guide them towards a decision on what to allocate. Does that make sense?
Yeah. Perfect. Thank you.
Well, Zayad?
Also, again, a question regarding Power BI. So from the slides here, what I can get actually is when we build a report using Power BI on Synapse, so the query should run faster.
Yes. Yes, okay. That is correct. So That's mostly because they're running this performance accelerator. Now, I would be surprised if this performance accelerator isn't also running when you use the Synapse data connector in Power BI on the desktop, for instance. I don't think there's something special about using this tab within.
Okay, so yeah,
Yeah.
my question is exactly using this integrated Power BI in Synapse. Does it make any difference if we use the Power BI portal or the desktop?
No.
No. Okay.
No, and I'll double check on that. But that would be I would be shocked because essentially this creation and optimization of materialized views, we're going to look at it in the lab. That's something that Synapse can do for really any tool. It's not necessarily just for Power BI. They just know that lots of users are using SQL Data Warehouse already. And so as that, has become Synapse, they want to take advantage of that platform and give it some specific features. But I don't think any of it's locked into, this web interface necessarily.
Okay, thanks. Actually, I have another question here, just posed. Maybe it's a bit in advance, but so what is the main benefits of integrating Power BI into Synapse directly? So which benefit can I get if I just run or connect Power BI, either desktop or the portal, to Synapse database? Or what is the benefit using this integrated Power BI in Synapse?
Well, so like it says here, you do get the ability to have automatic creation of those materialized views, and you get accelerated query performance. So basically, like if you're
disconnected just on me,
can everybody else hear me?
I think I lost connection, or you.
No,
okay.
Both of you are there.
It would be nice if you just maybe please repeat the.
Yeah, I can repeat, of course. So essentially, Power BI and Azure Synapse Analytics are obviously both.
I think I lost connection again. Do you hear me?
Yeah, I've been hearing you the whole time. Can you hear me?
Oh, sorry. I think the internet is no, me was just disconnected.
Okay.
So
no worries.
I didn't get anything. Maybe it would be nice if you just please repeat the answer.
Yeah. So Power BI and Azure Synapse Analytics are both coming from Microsoft, right? And that basically makes it so that Microsoft is able to implement certain, call them accelerators or features, that because they understand the underlying architecture of both, they're able to tune it towards that workload. So Azure Synapse is still going to be faster than Redshift if you're using it on Tableau, for instance, right? But when you're using it with Power BI, the specific Power BI performance accelerator for Azure Synapse automatically creates materialized views, and that results in that accelerated query performance. So if you wanted to, on something like Tableau or Looker, you could create those materialized views yourself, right? But the whole idea of accelerating a lot of this stuff is basically making it so that you can get best practices for your data warehouse and for your reporting engine with less clicks, right? And so by using Power BI and Synapse together, you're going to get that sort of whole picture of performance and automatic tuning. Does that make sense?
Yeah, it is. But so far, what I get related to the second question. So probably the same accelerator we'll get if we use Power BI service or desktop. Also, when we use the integrated one. should be.
Now I understand.
But the second, related second question, when you use the integrated one, so it's just like integrating Synapse and reach dashboards with less clicks.
Yeah, exactly. So the idea is like I could be, let me grab my laser. I could be up here writing like an ADF pipeline, right? Or doing a notebook to do some transformation on my data, right? I go ahead and click run. I'm able to click straight over to my Power BI tab and see what the impact of that operation was. So instead of jumping between multiple websites or multiple desktop applications, you get this kind of integrated, let's just say integrated development environment that's data focused for all your tools, whether it be low and no code ADF pipelines, whether it's Spark notebooks, or now even Power BI. It's just bringing all your tools together. There's nothing specifically fancy about running this in Synapse. Again, I will double check on that, but my understanding is that running this here or in the service or even in the new tab and Teams, all will have the same performance.
Okay, perfect. That's it. Thank you.
Yeah, thank you. Any other questions? Cool. So Power BI and Azure Synapse make it so that big data can be unlocked in a way that otherwise wouldn't be possible. So we've talked about how it's not uncommon anymore for companies to have petabytes of data across their organization. Analyzing and extracting insights from such massive amounts of data used to take hours. And so that's kind of the focus on the rest of the slide deck. So let's look at some highlights from a Forrester study that came out a couple months ago. And this is about quantifying the benefits to customers on average that are using Azure Synapse and Power BI together. So on average, organizations experience more than 250% ROI, 26% lower TCO, 27% faster time to insights, and 60% increased customer satisfaction. Procter Gamble uses Azure Synapse Analytics and Power BI to enable account managers, brand managers, supply chain planners, and analysts to make faster and more accurate decisions. The company generates insights into the consumer goods market with over 500 million queries running petabytes of data across hundreds of signals. And best of all, tens of thousands of employees at the company can access the data and visualize the insights. Azure Synapse and Power BI provides a massive opportunity for P&G to understand the market better. Today, Azure Synapse and Power BI are both available globally. System that is constantly growing. But before we pivot to the hands-on lab, I want to make you aware of the Microsoft Knowledge Center, where you can find plenty of samples and examples for Azure Synapse Analytics that have been designed to help you accelerate your understanding and adoption of the service. Specifically, you can use these samples immediately if you want a quick sample of how Synapse works. You can browse the gallery to link sample data sets and add sample code in the form of SQL scripts, notebooks, and pipelines. You can also tour Synapse Studio for an introduction to the basic parts that make it work. It's a great resource to share with your development and data science teams to help them also understand the possibilities of Synapse. Azure has multiple analytics packages to help you get started with your first project. With these offers, customers can quickly see the value that this package solution brings without complex overhead. Each of these packages provides qualified customers a free business use case consultation, a technical deep dive, software subscriptions, and hands-on technical expertise for the duration of the proof of value project. So there's some more details on that as well in that knowledge base. And so let me skip ahead here. So we're going to go ahead and take a quick break and then we'll get started with the lab. Lindsay is going to be dropping a link to a survey in the chat. While we get the lab set up, we'd ask that you all go ahead and take the survey. If you take the survey, that is how you get this deck emailed to you. So if we do not have your email from the list of survey participants, then you will not necessarily get the deck that we're going to send out. Aaron, do you have the provisioning details yet, or are we still waiting on that?
I have it.
Okay. Okay.
I just put it in the chat.
Okay, cool. Yeah, so if everyone needs to refill their coffee or whatever, that's fine. But then we'll have the survey and the details on how to set up the lab in the chat, and we'll go ahead and pick up there.
All right, just a quick check-in, everyone, as we're going to get started in a few more minutes. Has anybody had any problems getting logged in or getting their lab spun up?
We're currently looking on how to start the VM here, the virtual machine. Maybe it's still provisioning, but we can't actually start it, like the lab guide said.
Okay.
I don't know what you need to do. I guess
So for me, it tells it's up since 5 minutes, but the 5 minutes are shown for or displayed to me like for almost 5 minutes.
Let me share my screen real quick.
Yeah, sure.
So is this what it looks like right now?
Yep.
Okay,
And then
I
we
think
wanted to do the first steps on the right side, where it tells us to start the VM.
Yeah, so I think this is all okay because this is where mine is right now.
Okay,
as well.
perfect.
I was going to do it. For basically all.
And then I'll give just a couple more minutes because I want to make sure everybody's back.
I think the hallway.
All right, so let's get started. Everybody hopefully has had a chance to get the labs spun up and going by now. Just a couple of quick housekeeping things. Please do the surveys. Not only will it give us your contact information for the slides, but also it helps us understand what we're doing well in ways that we can improve. We want to make sure we're adding value to your day as you are taking time to be with us. So thank you. And then these labs, as a reminder, are on a time limit. So while I will be walking through them today with you, it is, if you skip ahead or go ahead of me, that's fine, but they will only be available today. So that being said, let's get started. I believe you guys can see my screen already. The goal of these exercises is really going to be to get you familiar with Synapse and the Synapse environment and the all the functionality it provides. So in the first exercise, we will explore data using, it says the engine of your choice, either SQL or Spark. Understanding the data through data exploration is one of the core challenges faced today by data engineers and data scientists. Depending on the data's underlying structure and the specific requirements of the exploration process, different data processing engines will offer various degrees of performance, complexity, and flexibility. In Azure Synapse Analytics, you can use either SQL Serverless Engine, the Big Data Spark engine, or both. So in the first tasks, we're going to go in and play with these engines. So to start off, we will browse the data lake using our SQL Serverless pool. We'll start by logging into the Azure Portal. You should have received a login and password with your lab information. So you'll go to portal.azure.com and log in with that information.
Sounds lovely. Do you think that do you guys have any extra the classic wrap? I know that the one that Austin got from Azure Wrap was like $40.
And so here's the basic interface of when you log into Azure. It should be pretty familiar if you've been in here or have any kind of experience with Azure before. let's click on resource groups. And you'll see your Synapse Analytics in a Day resource group. If you click and open that, one of the things you see down here is this SQL Pool 01. We're going to go ahead and click on this. And we're going to click resume. We want to make sure the pool is up and running so we can access it. Yes, we are sure we want to resume. And that might just take a minute or two. If anybody has any questions or any problems, just go ahead and you can unmute or put it in the chat. I believe Spencer and Lindsay are still around to help answer questions. While we're waiting on that to spin up, let's go ahead and go back to our resource group. And we're going to click right here with this hexagon, Analytics in a Day workspace. And we're going to open this, and this will open up our Synapse instance. On our Synapse workspace blade, we can open the Synapse Studio by navigating using this URL, or just opening Synapse Studio right here. And you'll notice a new tab opens. And here's the environment that Spencer described and talked about in the first part of this. This is the Azure Synapse workspace, and you will see we've opened it for our Analytics in a Day workspace. Let's hop over to these icons right here, to the one that when you hover over, it says Data. With this open, let's switch over to the linked tab. And under your Data Lake Gen 2 storage, let's expand this primary account right here. We're going to go under WWI, and we're going to navigate through the folder structure to get to a specific file. So we are looking for a Parquet file in 2012, Q1, and this first one, invoice date key. From here, you can right click and tell Synapse to generate a new SQL script and select just a top 100 rows. For anybody who has SQL experience, this is a very familiar syntax. Select top 100 all. From is very standard SQL, and this just tells you to query against the Parquet file. So let's make sure that this query here is connected to our built-in excuse me, pool. This represents our serverless SQL pool, and let's select Run. And this may take a minute if our SQL pool is still spinning up. I may have rushed that. You can see down here in your result set. This is a very familiar result set. So let's change this script up here, and we're going to load more than one Parquet file at the same time. In line 2, let's replace the top 100 all with just a count all. And then here on line 5, we're going to replace the path to the individual file, and we're just going to have it call all files in that folder structure.
You did a mass bulk load, right?
I'm sorry?
You did a bulk load, right? Because for me, it's only throwing errors when doing so.
It's showing an error?
When I select the fact table and then the Parquet files in 2012 for Q1, and I do a new SQL script for any one of them, I get just an error with no real information.
Is your connection set to the built-in SQL pool right here?
It does not even start this until there. Let me.
Can you tell?
Yeah.
Can you put the error in the chat?
Yeah, sure. I will put a snippet there. So maybe I lost a step there. Why server it doesn't found the resource group.
Okay. Give me 1 second, because I don't think that I saw that come through. Lindsay, did that come through?
When it came?
Yeah, it came through for me.
Okay. Let me hold on 1 second. I'm stuck on loading image. That's the problem. So from that screen, it looks like you're on. Can you double click one more? So it looks like it's possible you're on Q1 here, and you have this as a folder called Invoice Gate.
Okay, I found the error. I'm sorry. Yeah.
So
sorry.
Perfect. So in all openness, I ran through these last night as a practice for today, and I ran into a lot of little problems. So no worries with stuff like that. It's going to happen, and most of the time they're easily conquerable. So, all right, let's hop back over to my guidance. And where we were now is right now we are set to query from just a single Parquet file. We are going to update this link here to tell it instead of querying from a single Parquet file, we want to query from all of them in that particular folder. So we are just going to change this as soon as I can get the syntax. And this is probably in the lab work if you opened it through, but I'll explain in just a second. This link right here is pointing the query to a data lake, and then through that folder structure that we just navigated. And it's saying instead of going all the way down to a specific file, the stars indicate let's just read everything in that directory. So when you run this, since we're running a count all, you're not going to get the grid row set returned. You're going to get a number. So this is counting all rows from all of this, from all of the Parquet files in this directory. And we get, I'm eyeing that at roughly 2.9 million rows. So that's a way to use, excuse me, standard SQL for people who are familiar with that in this Synapse. So let's go over here. And when you click on this next icon down, it says develop. Let's click on this develop icon right here. At the top, it says exercise run, read with SQL on demand. And you already have a script here that has been generated for you. Let's make sure you are connected to your server pool, and let's make sure it's built in. And we're going to click run again. This query demonstrates the same functionality, except this time we're loading CSV files instead of Parquet files. Parquet files are compressed and stored data in columnar format for efficient querying compared to CSV files that are raw representations of data, but easily processed by many systems. You can often encounter many file types stored in data lakes, and it's helpful to know how to access and explore those files. For instance, when you access CSV files, you need to specify the format, the field terminator, and other properties to let the query engine understand how to parse the data. In this case, we determined that the value of 2 for the first row. This indicates the first row of the file must be skipped because it contains the column header. So let's come back up here to the Data Hub. And I'm going to close this just so I can keep everything in line for you guys. So we're back here at our original file, at our original Parquet file for January 2012. We're going to right click it. And this time we're going to add a new notebook and we're going to choose load to data frame. What this is going to do is generate a notebook with PySpark code to load the data into a data frame. And it should display 10 rows with headers, as right here, we are limiting the data frames to 10. Let's make sure our Spark pool is attached and choose Run All. And the first time you're in the notebook, it may take a minute for Synapse to create a new session and spin this up. So maybe only 2 to 3 minutes.
Or while we're waiting, can I ask a question here?
Of course.
Is it standard PySpark what we are using here, or is it a derived package from Microsoft? For example, I worked a lot with Dataworks and with standard Spark in the past. Can I also can I use the syntax from all my old notebooks, or will I have to update them somehow?
So I do believe it is standard PySpark. I believe it is, and Spencer can get me on this one. It's 2.7, 2 point something.
Okay.
And 3 minutes never seems long until you're waiting for a pool to start up. Yeah, if I had some background music, I would play it for you guys.
Spencer can sing for everybody.
Spencer kind of alluded to it earlier sometimes, and I'm guessing because we're all spinning up everything at the same time, it may take just a few extra minutes. I'm going to say seconds and be optimistic for everything to get going. While this is going, does anybody ever have any more questions about anything that we've covered today so far?
Tons of questions, to be honest. The first or the next one would be for the notebooks here while we're at it. Are there any hotkeys, for example, for running only one cell or something like this? Or is it only clicking?
I actually do not know the answer to that. I've never explored hotkeys. I can mark that down because that's pretty interesting, and I will get back to you on that.
Because I'm looking for it, I see the standard for undo stuff, but not, for example, F5 for running the queries. Yeah, okay, but with that said, yeah, sorry.
Oh no, I love all questions because if I don't know the answer, then I learn something.
Okay, then I'll check myself. Okay, perfect.
So as my file is running, I'm hoping everybody else is running now too. And you can see here, we now have 10 rows displayed in our data frame. Let's rerun this, but up it to 100. And now that the pool is up and running, it will return quicker. Look at how quick that was. So let's look at here at chart, and we'll notice these chart capabilities that will allow immediate visual exploration of our data. Right, so let's just click on chart here. And then right here, this icon says view options. We can do some basic filtering of our chart. So let's make sure right here at key, let's make it say customer key instead of sales key. And under value, let's have city key. And now click apply. Aggregation count is exactly what we want. So here was a quick way that we could visualize the data that we just ran. Now, if you're following along on the lab, here's a little bit of where this is going to differ. Let me go all the way down to the bottom here. The lab material says hover over the bottom of your cell and a little box will pop up that says add code or add text. That is an older version of Synapse that you can access if you turn off this preview feature. Please don't do that because it's going to refresh everything. The same functionality has been updated right here with this little plus sign. This little plus sign here will allow you to add a code cell or a markdown cell. So previously, if we were not in the preview, it would say add code or add text. So this is the way to add a code cell, and this is the way to add just if you want some descriptive text. Here we're going to add a code cell. And in this code cell, we're going to add this particular piece of code. And it's important here where it says your data lake name, we need to replace it with the data lake name that is assigned to you by the lab, which you can find right here in our previous cell. So just take ASA data lake and whatever yours is out of here. And we're going to put it right down here. And this is going to load data from, you'll see this time CSV files, still 100, and we're going to run this. So again, results the same. We just wanted to be sure to demonstrate the same functionality, loading CSV files instead of Parquet files. You'll notice right here in the file path, this says CSV. And so that completes the first exercise. How do you feel? Are you guys doing good? Let's go ahead and leave this open as we hop over to exercise 2. In this exercise, we're going to examine various methods for ingesting data into Synapse Analytics and our data lake storage. We will use notebooks and data flows to ingest, transform, and load data. So in this task, let's go over to develop here. And I'm sorry, my computer is locking up just a little bit, so give me just 1 second. And here we are. Let's click on this plus, and we're going to add a notebook. Let's make sure that this attaches to our Spark pool. And in this case, here's some Spark code that we're going to run. And again, we need to replace our data lake name with the name of our specific data lake. So we've left notebook 1 open, and we can just copy it right out of here. Perfect. Let's run this. Let's close this real quick. Okay, so as you can see, I am receiving an error that says my Spark job requested 12 B cores, however, the pool only has 0. Try ending the running job. I ran into this last night when I was running through it, and my solution was to knock up my Spark pool to 12 cores, which I promptly got an email from Microsoft that said, please don't do that anymore. So what we're going to do is, where were we? Develop. We're here. Under Attached Spark Pool, let's go to Manage Pools. And here's the Spark pool that you're running right now. And I have to remember how I changed this last night. We're not going to put it up to 12 cores because I don't want to get yelled at by Microsoft again. So under Spark Pool, we're going to click this little ellipsis, and we're going to do scale settings. And I just want to leave it at this because I don't want to get all of you in trouble with Microsoft. Did anybody else get this error? Is anybody else getting that error?
No, not yet.
Okay, well that's
not
good.
so far. Yeah,
That's
we are
good.
not so far.
If everything's running, then everybody's doing better than me. So Microsoft will like you more than they like me, and that's really what's important.
No, now I get the
So-
same error.
Okay. So I waited a few minutes, and I've kicked mine off again. So I think maybe the Spark is just going to take a few minutes to release the resources from the previous job that we did. So I'm going to say count backwards from 10 or 15 and then give it a try again because my session is starting right now and the pool is starting up. So I think it just took a few minutes to release the resources. As in any presentation, something was bound to happen, right?
Yeah, don't worry.
So what's going on here is this cell is importing required libraries here and setting our ALDS path, which is pointing to our data lake. Connecting to the ALDS Gen 2 from a notebook in Azure Synapse uses the power of Azure Active Directory pass-through between compute and storage. This Spark magic sets the cell language to Scala, which is required to use the Spark session library, which we're importing right here. Now let's add another code cell. And we'll paste the following code from the lab work into this new cell.
Could you maybe pass the link to the lab into the chat?
This code that I just pasted?
Yeah, or the lab where you're copying it from.
Yeah, so that was in the GitHub. Let's see. I feel like somebody's already on that. Yep.
Perfect.
And we are not that far down. Did you find the code there?
Yep.
We'll run this. Perfect. Good. So this code is loading data from the CSV files into the data lake in the data lake into a data set. Notice the option parameters here in the read command. These options specify the settings to use when reading the CSV file. The option tells Spark that the first row of each file contains the column headers and the separator is the pipe character, and that we want Spark to infer the schema of the files based on an analysis of the contents of each column. Finally, we display the first 5 records of the data retrieved and print the inferred schema to the screen. And when the cell is running, we can review the output here. Let's add another code cell. Here's the next batch of code that we're going to run. This code is going to write data retrieved from Blob storage into a staging table in Azure Synapse Analytics using the SQL Analytics connector. Using the connector simplifies connecting the Azure Synapse Analytics because it uses the Azure Active Directory pass-through. There's no need to create a password, identity, external table, or format sources, as it is all managed by the connector. As the cell runs, we're going to click on an arrow here. As soon as it comes up. This pane allows us to monitor the underlying Spark job and observe the status of each. As you can see, the cell is split into 2 Spark jobs, and the progress of each can be observed. And there's our second one. And this should take only about 1 to 2 minutes. And that succeeded. Great. Now that that's done, let's go back to data over on the left. And I want to make sure here that we close and discard our changes from this notebook. Kind of what I alluded to earlier, is make sure we free up all kinds of allocated resources on our Spark pool. Under this Workspace tab here, let's click on Databases. Let's look at our SQL pool and tables. This feels a lot like SQL Server Management Studio at this point, for those of you who have experience with that. Let's expand our tables and go down and find WWI staging.sale, which should be right down here at the bottom. If you don't see the table, select this action ellipsis and we'll click refresh. So if you don't see this table here, then right here, you can click actions and click refresh, because it may just take a minute to pop up. So we're down here on staging. Once you click on staging, we can generate a new SQL script and we'll top 100 rows. And this also auto-generates in a more familiar, this is a lot closer to Transact SQL if anybody has any familiarity with that. So we run this and we see our results grid down here. and this is interaction. So if you're following along with the lab work, there's a bonus exercise with the C# notebook. I'm going to skip over that in the interests of time. These labs are available today, and we do have 4 hours. So if you want to work through that, you're more than welcome to. But I would like to make sure we get through all of these exercises and have plenty of time for any questions. So is everybody good with, or do you guys have any questions with what we've done so far? For me, silence means everybody is happy. So for our next exercise, we're going to go over Power BI integration. In this exercise, we'll realize another benefit of the fully integrated environment provided by Azure Synapse Analytics. Here, we're going to create a Power BI report and build a visualization within Azure Synapse Studio. Once we publish the data set, we'll not have to leave this environment to log into a separate Power BI website to view and edit reports. The Power BI workspace we're going to work with has been created for us. So we are going to do another 2 tasks in this exercise. Everybody excited? Let's get started. Over here, let's click on Develop. And then we're going to go down and we're going to click on Power BI. So let's collapse all of these here and collapse notebooks. And you'll see right here is Power BI. So let's do this. And expand Power BI workspace. And you'll see Power BI datasets. And you'll notice there's nothing here. So we're going to click on New Power BI dataset. So the panel that shows up, it says create a Power BI dataset from a data source and publish it. You will need Power BI desktop on your local machine. So does anybody not have Power BI desktop installed? If you don't, there's a very easy link here that if you just click on it will take you, and I'm not going to do this because I already have Power BI installed, to the Microsoft Store where you can download it and install. I'm going to assume everybody has Power BI, so let's click Start. Here we're going to select the SQL pool that we've been working with and click Continue. And this is a Power BI that they've already provided for us that we're going to download, and then we are going to open in Power BI Desktop. So the instructions on screen is what we're going to follow here. We're going to open this file, and this will automatically launch our Power BI Desktop. So let's go here and find my downloads file and open this. And it's going to take just a second for that to open. When you open Power BI Desktop, you want to make sure that you are connecting it to the instance that we're working with here in this ASA. So we are going to go to the Microsoft account and click Sign In. Here we want to select the Microsoft account and sign in, and then use these login as credentials here that have been provided for us. I promise it's not the wrong one. And that should be the information that was provided to you with your lab information. And now you can see that we're currently signed in, and we're just going to hit connect.
Just a question, I just
Of course.
got lost. Which database should we connect to? SQL Pool 01 or SQL In Demand?
01.
Okay, the SQL Pool. Thank you.
I'm giving everybody just a minute to make sure that everything's signed in. Once the sign-in is complete, your navigator window opens up here with a list of tables. And for us, we're just going to worry about fact sales. So we're going to come down here to fact sales. And when you click on it, Power BI is going to preview the data and show you a preview of the data over here, just so you can see what you're looking at. And so, yes, we're sure that that is what we need. We're going to click on the little checkbox to tell it, yep, we're sure, we're confirming, and let's just get this loaded. And here in your connection settings is where you choose import, which would store the data in kind of like a Power BI engine. In this case, we went direct query because we want to directly query against our data source every time. So let's make sure that direct query is selected and then click OK. And we'll give Power BI just a minute to create those connections and create the model. And so back to the home canvas here, you can see that we have in fact connected to our fact sale table here. Because we're going to play in Synapse and not Power BI desktop, let's hop up over here and click on File and Publish to Power BI. Yes, we want to save our changes. And I'm going to call this fact sales because that's the data that we're working with. And here in this address, in this box, we're going to enter that email address that was provided by the lab. So the ODL_user. Like that. And hit connect. The publishing dialog box should be doing something. Yep, we're working on it. And we're going to publish to the workspace here. That matches your lab credentials. And success. We have published this out to Power BI. So let's click Got It. Now let's go back to our lab work, which is not there. And let's hit close and refresh. You'll see what we just published has popped up here in our Power BI data sets. So now you can open your Power BI data set here in Synapse. give a second for make sure everybody's with us. From here, if we would like to build a report off here, let's click on this. And on the hover, you see this little what looks like a Power BI icon. It says New Power BI Report. Let's just click this. This launches a new tab up here with a very familiar interactive environment here that looks a lot like Power BI Desktop. Now over here, you're not seeing your list of fields. This is how we're going to fix that. We're going to open another tab. And we're going to go to powerbi.com. And we'll sign in with the lab credentials again, which, because we opened a new tab, it fortunately looks like it did that for us. And let's go to the workspace for your lab. So here you see the report in the data set that we just published. So on our data set, we'll click on this ellipsis right here. And we're going to go down to settings. Our table was not showing up because here it says your data source cannot be refreshed because the credentials are invalid. Please update your credentials and try again. So what we're going to do here is we're going to click on credentials. And you'll notice our authentication method here is set to basic. We are going to set it to OAuth 2, which is basically an open source authentication protocol that allows the services to pass authentication back and forth. And we're just going to do sign in. And we're going to let that finish up for a few seconds. And we have success. So let's go back here and push refresh in the corner right here. And our data has shown up. So by changing that authentication protocol, we're allowing Synapse to connect to our Power BI service here and pass the data through. We're done with this, so we can close out this tab. So here in the Power BI Designer, here's our list of kind of pre-done visualizations that you can choose from. Let's go into the second row, almost all the way over, and hover over where it says line and clustered column chart. And this automatically puts the visual on the canvas for you. Let's add some context. And I'll make this over here a little bigger to make it just a little bit easier to see what we're doing. If I can get my mouse in there. I tried. Under the shared axis, we want the salesperson key. So we're just going to click on salesperson key and drag it into shared axis. Under the column values, we want to put total excluding tax. So over here is total excluding tax that we're going to put here under column values. And then under line value, we want profit. Perfect. Let's make this chart a little bigger so you can see what we've just done. And you've automatically created this visual with line and bar graphs. Here under the filters pane, you'll see a profit filter. Let's filter down our profit a little bit. And we want to show all the items where profit is greater than, and then we'll enter 50 million here. And click Apply Filter. So you can see the visualization has changed based on what we've just entered. We've narrowed down the results to only those where the total profit amount is greater than 50 million. Since we're using direct query, Power BI pushed down the filter to the dedicated SQL pool to execute the new query based on the parameters. the pool sent back the results to Power BI to re-render the chart. Since we are dealing with a vast number of records, there's over 12 million right now. Harnessing the dedicated SQL pool's power to aggregate and filter the data rather than importing it and using the Power BI engine is much more efficient. So now under the File menu, let's click Save As. And let's save this report as key sales by person. And click Save. So now you can see we've created another Power BI report that is available in your workspace for other users who have access to that workspace as well. Is everybody following along okay?
Yep.
Awesome. So now that that's done, let's hop over to Monitor. And we're going to take a look at the SQL query that we just did. So under Monitor, let's select SQL requests in the left-hand menu. So we're going to look at SQL requests. And we're going to look at our SQL pool 01, which is the one that we just did. And let's see if I can make this column a little bigger. Nope. Well, we want to look at this top 100 right here. So let's click on here. And here's the steps that the query went through. And you can see all of the different, everything that it went through. Go back here. And there you go. So this is just a way that you can go and see kind of what it's doing when you're doing.
If you click on this More button, we get the script on the right side. Yeah.
Here? Yeah. All right, we are moving right along. We are ready for exercise 4. Is everybody doing okay? Do you need to stretch your fingers? All right. I assume silence means either everybody's gone or everybody's happy. So we'll move through to exercise 4. And again, guys, just put in the chat window or something if you have any questions or problems, or Spencer said earlier, it's a small group, so feel free to just kind of blurt it out if you need to.
I have a question.
Of course.
So, as we have just seen, we could see 2 data sources to connect Power BI, the SQL pool and on the on-demand database. Is Power BI this integrated into Synapse, can connect to other data sources, to the Blob, or I don't know, on-premises, what Power BI desktop can do, or it is more limited?
So the Power BI here integrated into Azure Synapse Analytics works the same as a Power BI desktop. So if you can connect to it in the desktop, you should be able to connect to it in here. The advantage of here that Spencer kind of alluded to earlier is the idea behind Synapse in the integrated work environment is to democratize the data so everybody, so non-developers, non-data people can really find it easy to work with the data. So by putting it in here, it's kind of, it's the exact same functionality. It's just kind of in a friendlier environment for people who maybe aren't hardcore technical background. So if you can do it in desktop, you can do it here. Does that make sense?
Yeah, perfect.
Okay.
Thank you.
All right, so on exercise 4, we're going to use several of the capabilities associated with dedicated SQL pools to analyze the data. SQL data warehouses have been a long time the center of gravity in data platforms. Modern data warehouses can provide high performance, distributed, and governed workloads regardless of the data volumes at hand. The dedicated SQL pool in Azure Synapse is the new incarnation of the former Azure SQL Data Warehouse. It provides all the modern data warehousing features while benefiting from the advanced integration with all the Synapse services. So in this task, we are going to work with, we're going to do some high performance analysis with Azure Synapse dedicated SQL pools. So in this task, we're going to try to understand who our best customers are. So let's hop back here as we're still in our analytics pool. I'm going to go ahead and close out all of these extra tabs here because we're done with them and I just kind of want to keep my screen clean. So let's go over here to develop. And under SQL scripts, we're going to click on exercise 4, analyzing transactions. In my SQL pool here, we want to make sure that it says SQL pool 01. And then in this SQL query that's generated here, we're going to click run. And you can see we have results down here. Let's make this a little bigger so it's easier. Let's toggle over to chart. On the chart type, let's make it a column chart. We're going to leave the category for column is none. The legend series, we want it to be customer key. And so what this has done is you can see the volume by customer key generated very easily across all of these charts. And if we need to save this image, you can save it as a JPEG, a PNG, or an SVG file. So next, let's try to understand the implications of table design at a general level. We are going to run the same set of queries against 2 different fact tables, one called fast and one called slow. The 2 fact tables have the same structure and contain identical data, and there's one notable exception in configuration. So over here, let's open this, investigating query performance. And we'll start by running this one called slow. So highlight that and click run. And notice our quick response time and the results, 83.4 million records. If we configured our SQL pool to be a DW500C, then our results would be in under 1 second. So let's click online here again. And let's run fast. Did that not run? So that one did run a little quicker as well. So let's run this next chunk. And here we're really just comparing the query times so you can see the difference against the dedicated Spark pools. And this one we're going to rerun 3 to 5 times until our execution time stabilizes. The first run is usually called a cold run, and the execution takes longer than subsequent runs, who benefit from the initialization of various internal data and communication buffers. So this first one took 19 seconds to run, which is right about what we expected. So let's run it again and see if that performance improves. And yep, we're down to 8 seconds on that one. So quite an improvement. And down to 7. So with each run, it seems like we were getting better performance. And now let's do this last query for the same thing. You can see that first one took 22 seconds. So let's do it again and see if we can get that performance to improve. Perfect, it was down to 3 seconds. All right, does anybody have any questions so far? So we're on to exercise 5 now, which is data science with Azure Synapse Spark, which we can move on to if everybody's interested. We're doing a pretty good pace here, so we can take a 5-minute break if you guys are interested. But when reviewing my notes, I noticed there's another task that I skipped over in exercise 2 that helps us integrate with Azure Data Factory pipelines. So I will leave this up to the group. Would you guys rather work on the Data Factory pipelines with integration, or would you like to move on and do some explore a little bit of data science with Spark? Because nobody's answering me. I think that I want to go back to the Data Factory part to make sure that we cover that, because that is an important and exciting part of Synapse that I want to make sure you guys get exposed to. So I'm going to take 2 or 3 minutes to shift back to that and let kind of everybody catch up, and send my apologies for going out of order on this. So if you're following along with the GitHub lab work, we're going to be under exercise 2. And scrolling down past the bonus work, we're going to skip about midway down the page, according to my web browser, to task 2. It says explore, modify, and run a pipeline containing a data flow. So in this task, we're going to use a pipeline containing a data flow to explore, transform, and load data into an Azure Synapse analytics table. Using pipelines and data flows allows you to perform data ingestion and transformations similar to what we did in task 1 without writing any code, which is why I wanted to be sure we covered this because it is really exciting. So over here on our left-hand navigation menu, we're going to click on this little spool that looks like it looks like a spool that says integrate, and we're going to click on that. And then pipelines. And we'll click on exercise 2, it's enrich data. So by selecting the pipeline, it opens the pipeline canvas where we can review and edit the pipeline using code-free graphical interface. This view shows the various activities within the pipeline and links the relationship between those activities. In this, our pipeline contains 2 activities, a copy data activity named import customer dimension, and a mapping flow activity named enrich customer data. So let's take a closer look at each of these within the pipeline. Let's select the copy data activity first. First, let's select the source tab. The source defines the location from which the activity will copy the data. The source dataset field is a pointer to the location of the source data. You'll notice data is being retrieved from the files stored in the data lake, which is what this is pointing to right here. Next, let's select the sync tab. This sync specifies where the copy data will be written. Like the source tab, the sync uses the dataset to define the pointer to the target data source. Let's select polybase for the copy method right here. This improves the data loading speed as compared to the default setting of bulk insert. So polybase, click. I just wanted to scroll through to make sure you guys saw all the different settings you can do here. So notice the fields on the tab. It's possible to define the copy method, the table options, and to provide pre-copy scripts to execute. Also notice the sync dataset. The dataset requires a parameter named unique ID, which is populated using a substring of the pipeline run ID. This dataset points to the unique ID tab in Synapse Analytics, unique ID table in Synapse Analytics, which is one of the data sources for the mapping data flow. We'll need to ensure that that copy activity successfully populates the table before we actually run this data flow, but we will be sure to do that as we work through. So let's work onto the mapping tab. Here we'll review and set up our column mappings. Just letting you see all that. If you notice, what we're doing in this column mapping here is the data source customer key has spaces in these column names. Over here, we're just removing these spaces in the column names. And finally, let's go to the settings tab. So in the settings, let's be sure to check enable staging. And let's expand staging settings like this. And we'll select our data lake. which is going off my screen. So we'll just click New. We want to connect it to our data lake. We want to make sure it's a link service. Create. And now we've, using a link service, connected this to our data lake. And down here, now that that's in here, our storage path, we're going to type in staging and be sure to enable compression. Since we're using Polybase with dynamic file properties, owing to the unique ID values, we need to check enable staging. In the case of large file movement activities, configuring a staging path for the copy activity improves performance. Let's go to the mapping data flow activity. Up here and explore this one a little bit. Here we'll go to the settings tab. You can see that the data flow enriching customer data is here and our unique IDs are here. And let's just go look at parameters. And notice our unique ID is still here as well. So let's look at the data flow definition in this mapping data flow activity. Let's double click here. And this opens up the underlying stuff. So typically, when working with data flows, you would want to enable the data flow debug to create a Spark cluster to use for interactively testing each step of the data flow. And it would allow you to validate the output before saving and running the data flow. Enabling the debugging session can take up to 10 minutes, so we're not going to do it for this workshop. They have provided screenshots to provide details that would otherwise require a debugging session. So we'll show you that here once we get down there. So just know right now that we're not going to do this debug. In this data flow canvas, oh, hold on one second. My computer is doing weird things again. We can see all the constructs that make up this data flow. So from a high level, this data mapping data flow comprises 2 data sources, and each component contained within it in greater detail. The two data sources, multiple transformations, and 2 sinks, which is right here. The data source components, postal codes, and DIM customer ingest data into the data flow. The enriched customer data and enriched data ADLs, right over here, are used to write data to the data stores. The remaining components between the sources and the sinks are here, and these are the transformation steps. Let's go into these postal codes in greater detail here. So double click on that, and it's going to open this down here. On the source settings tab here, you'll see properties similar to what we saw on the pipeline activity. The name of the components can be defined along with the source dataset and a few other properties. The postal codes dataset points to a CSV file stored in an Azure Data Lake Storage Gen 2, which is pointed to right here. If we go here under the projection tab, the projections tab allows you to define the schema of the data being ingested from a data source. A schema is required for each data source in a data flow to enable downstream transformations to perform actions against the data source fields. Please note that by selecting import schema requires an active debug session to retrieve the schema data from the underlying data source, as it's used the Spark cluster to read the schema. So if you look here, we're using zip code and we're changing it to a string. We're forcing that into the schema to make sure that any US zip codes, which are all numeric, 64151, 64152, 02320, all maintain their leading zeros. An integer will tend to drop a leading zero, and we want to make sure that those leading zeros stay because they are important. And this highlights an example that it's essential to review the schema to ensure the correct types are set, both for working with the data and to make sure it's displayed correctly. So this data preview tab was what allows you to ingest a small subset of data and view it on the canvas. This is the functionality that requires the active debug session for the workshop, which we're not doing, but I have the screenshot here that will show you if you clicked on data preview. This is what it would look like. So you can see the data that you're working with and validate everything is as you would like it. Any questions up to this point?
No, looks good.
Great. So let's hop back here. And actually, I didn't want to do that. I want to come back here. And I want to look at this plus here. This brings up in the menu to learn about, and you can explore this and learn about each of the transformations. Microsoft provides a mapping data flow transformation article that can explain in depth what all of these will do. This I just wanted to highlight is where you go see. I want to make sure that you guys didn't miss this menu right here. So let's hop over to this postal code filter. And let's do a single click, and we can look at the settings and configuration on the bottom. Here is our filter where we put the filter, and let's just double click on that. And this brings up a greater filter panel where you can visually build your expression to whatever you may need it to be. Many transformation properties are entered as expressions. These expressions are composed of column values, parameters, functions, operators, and literals that evaluate to the Spark data type at runtime. So here's all. We'll just take a minute to look at all the different ways you can explore this. And then we'll hit cancel. So if we read this, it's currently set to filter all zip codes between 1 and 90,000. Observe the different expression elements and values that are in here. So in this case, we're using a greater than or equal to or a less than or equal to. So let's hop out of this. And we're going to select here on DIM customer next for our other data source. So in this case, our data source relies on a different data set, obviously. And it does rely on the unique ID and the source options. And now let's hop on join on postal code. This join settings tab allows you to specify the data sources being joined and the join types and conditions. Notice here that our right stream points to the postal code's data source, point to the postal code filter, and not the postal code data source directly. By referencing the filter data set, the join works with a smaller section of postal codes. For more extensive data sets, this will provide a performance benefit. And here we've chosen an inner join versus left, right, outer, customer cross. So next, let's select desired columns as we work through this. So noticing that the select desired columns, and I can scroll down so you can see this, appears twice in this graph. To enable writing the resulting datasets to two different sinks, Azure Synapse Analytics and Data Lake Gen 2, a conditional split is used for multiple outputs when it's required. The split is displayed in the graph as a repeat of the split item. So here they've used a conditional split to make sure that we're writing out to two different data sets. So here under the select settings, we have the desired columns. We're skipping duplicates. Here's all of our options. And again, we're not going to do the preview because we're not in debug mode. I just wanted to be sure that you guys were able to see all of this. And so finally working through this, let's look at this last sync here. And we'll click over to the settings tab, and the settings tab defines how the data is written into the target table in Azure Synapse Analytics. The update method has been set in this case only to allow inserts, and the table action is set to recreate the table whenever the data flow runs. And scrolling down here, we have our list of scripts. So it should be pretty familiar to anybody who has worked with Azure Data Factory. Do you guys have any questions about this right now before we head back to the canvas and start to run it? Okay, so let's just close this tab and we're back on our canvas. You'll notice here that we have this green box at the end of each data flows. If you click on this and drag this up, it will connect the flows and specify that we start here, and then after this runs, we're going to run up here. It creates the requirement that the copy data activity completes successfully before the data flow can execute, and enforces the condition of Synapse Analytics table being populated before running the data flow. So data is copied, and then this one is done. So the last thing we're going to do before we run this pipeline is publish the changes we've made. So let's look at publish here. So it gives us a chance to review the changes we've made, and we're going to click publish. And within a second here, it should say success. Publishing, great. My pipeline is now ready to run. We want to add a trigger to kick it off. So we're going to click on add trigger, and we're going to trigger now. It's got our little warning that it's published, and we're going to run using the last configuration. And so we're going to click OK. Now we want to go monitor this pipeline while it runs. So we want to watch how it goes. So over here, we're going to go click on monitor. And of course, we want to go up to pipeline runs this time. And we want to click on this one, enrich exercise 2, enrich data flow. And this view is a graphical representation of the activities within the pipeline, as well as the list of the individual activity runs. Both provide status indicators for each activity. So let's give us a little more room here. And you can see the first one has already succeeded. This view allows us to monitor the overall status of the pipeline run and observe each activity's status within the pipeline. The screen will auto refresh for 5 minutes. If auto refresh does not occur or your pipeline run takes longer than 5 minutes, you can get updates by selecting the refresh button on the Canvas toolbar, which is right here, you'll notice. So let's get a better understanding of the types of information we can get with these monitoring capabilities. So we'll explore what's available for each activity. Let's hover the cursor over our mouse here. And you notice this says input, and this says output, and this says details. Let's click on the output dialog box. In the output dialog box, we see details about the size of the data read and written, the number of rows read and copied, and the duration of the copy activity, and some other information related to the run. This information can be used for things like troubleshooting. For example, you can compare the copy run to data such as the number of rows read and written to get unexpected numbers from the source in the sink. And let's close that. Now let's look at the input. Kind of the same thing. And now we'll look at the details. The details dialog provides the data found on the output dialog examined above, but expands on it to include graphics for the source, staging, storage, and sync, and a more detailed look about the activity run. So data read, how long it took to copy, start time, all kinds of helpful information if you're troubleshooting or doing performance optimization. So let's close this. Click on refresh. And you'll see enrich customer data is currently in progress.
Do you know if there's some capability to put the logs into Azure Monitor or into Azure Blob storage?
I actually, Spencer may know the answer to that one. I personally do not, but I can certainly look into that. So
Yeah,
that feels like something
no
I
problem.
need to know.
Don't worry.
I'm trying to give this a minute or so for this to finish. If it doesn't in the next few seconds, we'll just keep going. And it looks like it's succeeded. Great. So let's hover our cursor over here on Enrich Customer Details and look at this details page. And this brings us to a full screen view of our data flow. So this initial view provides the details panel containing statistics for the sinks defined within the data flow. The information for these includes the number of rows written and the processing times for writing to each sink. So number of rows and how long it took. So let's select these here, select desired columns. So by selecting any component in the data flow, it opens a new panel with details about the processing that occurred in that flow. So how many columns were total, how many were updated, how many were dropped, rows calculated, partitions, time. Again, all for keeping an eye on optimizing your data flows. So let's try it and see what's under here under enrich. And you'll see the same. And see the information available. So let's close this dialog box. And here, let's click on Gantt view back on this main screen. This view provides a graphical representation of the run times of the various activities within the pipeline. You can see the import customer dimension and then the enrich customer data. And this is a good visual representation of how long it took each to run. And this is really valuable when you get into more than just 2 steps, right? So you can really see the progress through here and track the times. So next, we're going to examine the Apache Spark application monitoring capabilities built into Synapse. The Spark application monitoring screens provide views into the logs for the Spark application, including a graphical view of these logs. So let's go back to monitor over here. Now we're going to click on Apache Spark applications. On the Spark applications page, we want to filter on submit value, so only stuff for the last 24 hours. So what local time? We want to do last 24 hours. And click OK. So from here, let's just click on that first job that has the status as succeeded. On this data flow screen, we'll see a detailed view of the job broken down into 3 different sections. The first section is the graphical representation of stages that make up the application. The second is the summary of the Spark application, which is supposed to be here and of course not for some reason. There it is. And the third section displays the diagnostics and logs associated with the Spark job down here. So no field jobs is always a good thing to see. Let's select logs. Here, and that's unreadable. There we go. You can look at your logs, files, and then here's some filters that are provided if you want to filter and parse through your logs to find a specific anything. And you have the ability to download your log files if necessary. So up here, selecting on any individual stage from the graph opens up a new browser, showing the selected stage in the Spark UI where you can dive deeper into the tasks that make up each stage. So let's click on View Details. And here's all the information we have about the stage 3. So duration, how it's comparing to others, some aggregation metrics, and tasks. Let's go back to this Spark monitoring page now. Let's take a closer look at any individual stage. We can still filter here on job ID. Let's choose 3. And that filters it down to just stage 3 in our graphical view. Go back to look at all jobs. Now, and this is helpful, again, when there's multiple stages and this canvas can get very cluttered, to be able to filter it down to just the one step that you're looking for. You've noticed within this graphical representation here, you have a playback button. The playback functionality is not going to be available until the job status changes out of the in progress. So you have to wait till your job is done. Running the playback allows you to observe the time required to complete each stage, as well as review the rows or read the job in progress. So let's just play. And it runs you through. So it is important to note that you can also do playback on any specific stage if you would like. So you can narrow down to job 3 here and do playback. Or you do all jobs, you click. There was a way to do playback here as well. So you can also change the view to see what stages involved with the read and write activities. So let's make sure all job IDs are selected, and then under view, let's just see which ones are reading. You can see which stages perform reads with each color coded and how much data was read, right? So it gives you the average, and then you can see based on the color scale where the heavy read writes are, which ones aren't so much. And so it's important to note what we've done here in this one Synapse Studio environment is we've ingested the data, we've connected it to our data lake. We've manipulated and shaped data here, and then we've also been able to integrate and create the Power BI reports, all with this integrated analytics. Are there any questions about the Spark pool jobs and the monitoring that we just did, or about what we've covered so far?
Looks good.
So we are coming right about noon. Do you guys want to get into the data science part of this now with Synapse Spark, since we do still have time?
With pleasure, but maybe we can have a break, 5-10 minutes.
Sure.
Yeah, just a technical break would be fine.
Okay, yeah, so let's take, it's 11:56 to me right now. Let's come back at, we'll say 12:05, and we'll walk through some data science in Spark.
Yeah, thank you.
Okay. All right, is everybody or at least one person back? Couple more minutes, or one more minute, and then we'll get started. All right, so let's get started going through our data science exercise here. So Azure Synapse Analytics. Hold on. Azure Synapse Analytics provides support for using trained models in ONNX format directly from the dedicated SQL pools. What this means for you in practice is that your data engineers can write T-SQL queries that use those models to make predictions against tabular data stored in your SQL pool database tables. In this exercise, we're going to leverage previously trained models to make predictions using the T-SQL predict statement. So I'm sharing a screen with you right now, just to give it a little bit of context. These are some high-level steps taken to create Spark ML-based models and deployed so it's ready to be used in T-SQL. So you can look at the steps here graphically. The model is created and stored and registered, and then all the steps used for the models. These steps are performed using a combination of Azure Databricks and Azure Synapse Analytics workspaces. Within a Databricks notebook, a data scientist can train the model using Spark ML, the machine learning library included with Apache Spark. Models can also be trained using other approaches, including by using Azure Machine Learning Automated ML. The main requirement is that the model format must be supported by the ONNX. So the data scientist also will convert the model to ONNX format by using the ONNXML tools. And they will also save a hexadecimal encoded version of the model to a table in the SQL pool database. In order to use the model for making predictions in Synapse Analytics in a SQL script, a data engineer will read the model into a binary variable by querying it from the table in which it was stored. And then the data engineer can execute a query using the from predict statement as you would a table. This statement defines both the model to use and the query to execute that will provide the data used for prediction. You can then take these predictions and insert them into a table for use by downstream analytics applications. And in case you're curious, ONNX is an acronym for the Open Neural Network Exchange and is an open format built to represent machine learning models, regardless of what frameworks were used to create the model. This enables model portability, as models in the ONNX format can be run using a wide variety of frameworks, tools, runtimes, and platforms. Think of it as a universal file format for machine learning models. So in this exercise, we are going to make predictions with a trained model and possibly examine the model training and registration process. So in this first task, we're going to author a T-SQL query and use a pre-trained model to make predictions. So let's hop back over to our Synapse Studio. We're going to go over here and click on data. And we're going to use our SQL pool. And we're going to generate a new SQL script. And this time we're going to do an empty script. And let's just close this because we're done with this. And we're done with this. And if you're following along still in the lab work, we'll copy and paste this SQL script. And then we'll click run. I'm getting an error that says the function predict expects a parameter runtime that was not supplied. So we'll make sure my SQL pool is correct. Did anybody else's query run, or are you guys all getting the same error?
I'm currently fixing it.
Yeah, Aaron, I'm gonna post something in chat. I think
Okay.
you just need to specify that you want to run it with O, N, and X.
Okay.
I don't know why it's not defaulting to that because the documentation shows that it is optional, but
And Spencer, did you put that in the chat?
And also the
You did.
data table is not correct. You need to change up. I posted the whole script in the chat.
So, did you guys get it to run okay?
Getting the same stuff like you. There's no table for the data.
So while we working this out, once we get it to run, you will see the ideal output here is this prediction column, which is the model's prediction of how many items of the kind represented by stock item key that the customer will purchase. So that is the prediction that is being run, and we will work on why that isn't running. What does this error say? Spencer, have you seen that before?
Yeah, it's the shape of the vector. So input column.
Spencer is our resident data scientist.
Yeah, go back to the error. Input column. Yeah, so it looks like, and Christian might have been alluding to this, that we need to select just one row from that. So see how he's got select top one. No, you got the top one. Go ahead and in another tab, just show that sample data, and we might be able to see what's going on with that column. So just open a new SQL query.
Mm-hmm. And do you want to run a select all?
Just on
From
the
sample data?
WWI, yeah, sample data. Yeah, this lab is new, so I actually have not seen it in action yet. Yeah, so I think this is what they mean. So we have two columns, and I think it's just expecting one. Go back to the error message. Yeah, so it's just telling us it's not supported. It's not telling us the shape that it's expecting. Double check the code from the lab script and make sure that I know you just copy and pasted it, but make sure there's not like a predicate or something that we needed to do with the sample data. Like we might be missing a step where we were supposed to vectorize it. Did anyone get the prediction query to run yet? Steps 5 and 6.
No, I checked the GitHub and it's only full of issues for this task.
Okay.
Of this exercise.
Not surprising. A lot of the ML toolkit is still in active development for Synapse. Sometimes we're going to run into issues like that. Okay.
Actually, I also tried once this lab a little while ago, and actually I ran into error. I don't exactly remember the same error message, but this machine learning also steps didn't work for me.
Okay.
So
Okay.
it's the instruction.
Gotcha.
It's missing.
So, and I don't see anywhere where we're vectorizing anything in the lab instructions.
So that's probably what it's missing. Let's go ahead and, we'll have to mock it up instead of run it, but let's go ahead and just keep walking through the lab and just move past this step.
Okay, so that actually completes task 1 of this particular exercise. It was supposed to be, like I showed you the graph a second ago, predicting how many items this particular customer would purchase based on past activity. So Task 2 is going to be examining the model training and registration process. So in this case, we're going to open the Databricks workspace and navigate to the workspace section. So if your Azure Portal is still up, we'll head back to resource groups. And we'll click into our resource group, and of course my session expired. Nope. And here listed in your resource group, the last time we clicked on this Synapse Analytics Studio, here we're going to click on this top one, which is Databricks. And this opens our Databricks blade, and here we'll launch our Databricks workspace. So over here under Workspace, we're going to go to Shared, and then we're going to look at Exercise 5 Model Training. And this is the notebook that handles training the model, converting the model to the ONNX format, and then uploading it to Azure Storage. It is possible that when we look through here, we find out why our data set wasn't right. If we execute this notebook, it'll get the trained machine learning model into the proper ONNX format. So the point of this exercise is to read through and understand this particular notebook and how it works. We don't actually need to run it.
And we can walk through it cell by cell if there's interest. I don't know if people are more comfortable reading it on their own or having us walk through it, but it's up to you guys.
It is important also, per up here, if you do decide to play with and run this, anywhere you see these data storage account names and whatnot, replace it with your data lake in your data source to make sure it runs properly and you don't get any additional errors. Like here, in here, you would just want to replace it with your names.
Right.
Do you guys have any questions about Databricks or training models?
No, not from my side. In which storage account would it go? In the Blob storage. Okay, I see. Sorry.
So this section that I'm reading through right now looks like where it configures our prediction data set. So I'm going to read through it and see if I can figure out where our vector flaw was, I believe. And guys, just to let you know, this really does wrap up the lab work as well. So Spencer and I will stay on for a little bit if you guys are still working through anything or if you have any questions. And don't forget to do the surveys to get copies of the slide presentation that Spencer did earlier. Any other housekeeping, Spence, Lindsay, that I need to cover?
I don't think so.
Nope. Just the survey.
Just looking, how would you load the model once you create it into the SQL Server? I only see it here into the storage account.
So you're creating the model file in the storage account, and then the SQL Server will pick it up based off the location that's registered.
Okay.
That's why we were using the ONNX format.
Okay. When will the lab environment shut down?
At 2 or in 1.5 hours.
Okay. Then I would go ahead and just test it a little bit on my own, to be honest, in Databricks, and then check how I can use it in Synapse.
Yeah, that works.
Perfect. Yeah, then I will drop out. I will thank you all for the great help you provided to me, and have a nice day.
Yeah, thanks, Christian.
Thank you.
Just a question regarding the survey. Do we have to do another one, or the one you have already sent?
The one from earlier is fine.
Yeah.
Just the one you sent at the beginning.
Correct, just before the labs. I think Lindsay put it in the chat window.
Yeah, so it's already done. Thank you. So is it almost the end of the presentation, or do we still have any sections?
No, the presentation, for my part, the presentation is done. We worked through all the lab work. So really, this is just kind of work time for you if you want to work through any of the labs or have any questions or just need any additional time. But there's nothing else to present.
Okay, nice. I think also I leave because it's already late here in Germany. It's 7:30 p.m. We'd also thank you a lot for the presentation. It was interesting. And hope to see each other in future once more.